Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for minimum window substring problem. Let's look at the problem description. So we are given two strings s and t of length m and n. We have to find the minimum window substring of s such that all the characters in the substring t is present in that window. If there is no such substring, then we have to return empty string. Let's take a look at the example 1. So the input is the string and second string is ABC. So in this there are two substrings which has all these three characters. One is starting from index 0 to all the way is this C. 0, 1, 2, 3, 4, 5. 0 to 5. So the window length is 6. 5 minus 0 plus 1. And then another substring is B, A and C whose length is 4. So the minimum window is 4. So we have to return the output B, A and C. So in this case there is only one character and that character matches, so the output is A. And in this case the input string is A and the second string is longer than this A. In this case we cannot find a substring in S, so we have to return empty string. So M is the length of the first input string, N is the length of second input string. So the value of M and the length of these two strings ranging from 1 to 100,000. S and T consists of upper and lowercase English letters only. So we have to find an algorithm with the time complexity order of m plus n. Let's take a look at the approach to solve this problem. So we have the input string which has ACB, BACA, and the second string is ABA. So the expected output is BACA. So this is the smallest window. So we have to return BACA. So we can use the sliding window approach to find the smallest window which contains the letters in the second string, all the letters in the second string. So we have two pointers, start and end, and we extend the end pointer until we find all the characters in the second string is present in the window starting from start to end. If all the characters present in it, then we find the window size between the start and end and then compare it with the current minimum window size. If this new window size is less than the previously computed minimum window size, then we will remember the starting point of the new minimum window. So we will update the start IDX with the current start pointer, and also we update the minimum window size in order to check whether all the characters are present in the window. We need some metadata, which is how many times each characters occur in this second string, and as we see that character we have to update the count which reflects the current number of characters we have seen so far. So for example, if we look at it, this map, this is the character A. Maximum it occurs 2 times in that substring, and B occurs only once. When the program is beginning, at that time we initialize the current count to 0. As in when we see the character A or B, we increment this count. Using these frequency and the current count, we can determine whether all the characters in the second string is present in that or not. So we do repeat this process until the end pointer reaches the end of the string. So when the end pointer reaches the end of the string, finally we have the minimum window. Let's look at the flowchart. Input for this procedure is input string inp and then the second string sub. First we initialize the start and start IDX and end pointers, and then we set the minimum window size to maximum integer value, and then we initialize the inp count and sub count variable with the length of inp and the substring. Next we build the char count hash map, which basically contains the frequency of each character in the second string, and also it contains the information about how many times so far that character is seen in the current window. Next we enter the for loop. There we check whether we reach the end of the string. If so, we will go out and return the output. If we haven't reached the end of the string, then we check whether the current character we are seeing is present in the hash map. That means that character is part of second string. If so, we check whether the occurrence of that character has reached its frequency, the maximum number of times that character is present in the second substring. If it is not yet reached that, then we decrement the sub count. Basically, we are accounting how many characters in the second substring we have seen so far. The moment this sub count reached 0, then we can conclude we have seen all the characters in the second string. So that's why whenever the character is not reached its maximum frequency, by decrementing this value, we are counting that we have seen that character. If it is already reached the maximum frequency, then without decrementing the sub count, we simply increment the count field in the hash map. And if that character doesn't exist in the hash map, that means that is some random character in the first string. So we check whether we have seen any character so far that is part of the substring. If we haven't seen any character that is part of the second string, then we simply increment the start pointer, because the start pointer always have to point to the character which is present in the second string. So in order to meet that, because we want to compute the minimal window, if we accumulate, if we leave the pointer point to some non-existing character, then the window size will be bigger. So to avoid that, we skip the characters which are not present in the second string. That's why we are incrementing the start pointer if that character is not present in the hash map. Otherwise we just skip it, and then we come to the end of the loop body, and there we check whether the sub count equal to 0. Did we see all the characters present in the second string in this current window? If yes, then first thing we do is we try to do some cleanup. Sometimes we ended up having some unnecessary characters in the beginning of the window, so we wanted to get rid of those characters, and then we compute the current window size, and then we check whether the current window size is less than the minimum window size computed so far. If so, update the minimum window and then the start idx to remember the starting point of that minimum window which has all the characters. If the current window size is greater than the minimum window size, we just simply ignore that, and then we proceed with the next iteration, incrementing the end pointer, and then we repeat this process until we reach the end of the string. Once we reach the end of the string, we come out, and then here we check whether the minimum window size we computed in that loop is equal to the originally initialized value max int. That means there is no sub window which has all these characters present in the second string. In that case, we have to return an empty string. Otherwise, we will return a part of this first string starting from start idx up until start idx plus the minimum window length. That will be the output. Let's move on to coding. First I declare the character metadata structure, which contains the frequency of character and then number of times seen in the current window. Next I change the input parameters name. Then I initialize the int count with the length of first string and sub count with the length of second string, and then the start and end pointer will be initialized with 0 and start idx as well. Then minimum window size is initialized with the max int. Next I initialize the character count map. This contains all the characters present in the second string. Then we populate that information into that map by iterating over the second string. If the entry is already there, I increment the frequency. Otherwise, I create the new literal and assign for that new character in the hash map. Next, I write the for loop to process the first input string. So this will run until the end pointer meets the input count. So first we check whether that character is present in the char count map. If it is not present, that means the current character we are seeing is not part of the substring. So in this case, we have to check one condition where we haven't seen any characters present in the substring so far. In that case, we can skip these characters because we wanted to find the minimal window size. So we can skip the unnecessary characters. So that's the condition I am checking here. So we are seeing the character which is not part of the substring, and if the sub count is equal to the length of second string. In that case, we simply increment the start pointer and advance and continue. Else, we are seeing the character which is part of the second string. In this case, if the current number of occurrence of this character in this window is less than the maximum allowed frequency, then we decrement the sub count to keep track of how many characters we have seen. And then regardless of whether we reach the maximum frequency or not, we increment the count value. So I'm just adding the comment n character is part of the substring, update the count. Because if the end character is not yet reached the maximum frequency, then decrement the sub count. Next, I check whether the sub count is 0. That means we have seen all the characters in the second string in the current window. So whenever we hit this condition, we have to compute the current window size and compare it with the previously computed minimum window size, and whichever is less, we update the minimum window size with that value. We may end up having unnecessary characters at the beginning of the window. We just wanted to move past those unnecessary characters, so we make a call to the function ignore extra characters to advance the start pointer. Then I compute the window size and then update the minimum window size variable accordingly. And also we remember the start IDX, which points to the minimum windows starting point. After this, I will be sliding the window one position. So I make a call to the slide window function. After coming out of the loop, I check whether the minimum window size is still the max int. That means there was no window which has all the characters present in the second string. In that case, we have to return an empty string. Otherwise, we have to return a part of the first string starting from the position start IDX till start IDX plus min window size. Next, I am writing the ignore extra characters function. So this will basically advance the start pointer until we reach the first character which is part of the second substring, and also it has only the maximum frequency occurrence. So I check the first character of the window is present in the hash map. If it is present and that character occurred more than the frequency time, then I simply decrement the count. Else, the moment I hit the maximum frequency limit, then I break out of the loop. So I just added the comment. If this character occurred more than frequency time, then decrement the count variable. Finally, I return the start pointer. Next, I will be writing the slide window function. Here I check whether the first character is present in the window. If so, I decrement the count, increment the subcount value. Next, I advance the start pointer. So after advancing the start pointer, the new window may have some unnecessary character at the beginning of the window. So we have to ignore those characters. So here I am making the call to the ignore extra character function and get the new start pointer. Then finally I return the start and the subcount value back to the caller. Next I am going to run the test cases. Some compilation error. I think there is a typo. Okay, all the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do a code walkthrough with sample input. We are given input string ACB, BACA and the second string ABA. The expected output for this input is BACA, which is of window size length 4. Let's do the code walkthrough. So to begin with, the start and end pointer are pointing to the first character. So we are initializing that with the 0. And then the int count and sub count are initialized with the length of the first string and the length of the second string. And the start IDX variable is initialized with 0. And the minimum window size is initialized with the maximum int. And the char count map is initialized with empty map. Next we populate this map with the character frequency. So after building that, for this input in the second string a occurred 2 times, so the frequency field is 2 and the current count we haven't entered the loop yet, so that's why it's 0 and b is occurring only once. Okay, next we enter the loop in the iteration 0. Initially the start and end indexes are 0 and the start IDX is also pointing to the first character and the sub count is the number of characters in the second input string, which is 3, and the min window size is 32767 max int value. So first we do check whether the current character is present in the second string by checking the map. Okay, so in this case it is a, so that character is present, so we updated the number of occurrences so far in the current window, so 1, and then the sub count will be decrement it. So we are hitting this condition. So this condition is for the character which are not present in the second string, and this else part is for the case where we are seeing the character which is part of the second string. In that there are two different scenarios. One is whether we hit already seen max frequency number of characters in that current window or not. We check whether the current number of occurrence is less than the maximum frequency of that character in the second string. In this case it is true because maximum frequency of A is 2 and we have seen so far only once. So we decrement the sub count, so that's why we see 2 at the end of iteration 0, and then we increment the count value, so we are seeing 1. In the iteration 1, then the end pointer points to the second character which is C, that is not present in the second string, so we are entering this condition. This condition is false because the sub count is right now 2 and the length of second string is 3, so we are not hitting this condition. Then we come out and we check the sub count is 0. In this iteration as well as the previous iteration, the sub count is not 0, so we are not executing this piece of code and we proceed with the third iteration. So there is no change, only the index is advanced. Then we come to the iteration 2 where the end pointer points to the character B which is present in the hash map. So we check whether the current number of occurrence in that window is less than the maximum frequency. Yes, it is. So we decrement the sub count. So the sub count becomes 1 and then we increment the count value. So the count become 1. It was 0 in the previous iteration. Now it is incremented to 1. Next, in the third iteration, the end pointer points to B. Check whether that character exists in the hash map. Yes, it is. And we check whether the current number of occurrence is less than the maximum allowed frequency, but in this case it is not. So we are not decrementing the sub count. Instead, we simply increment the number of occurrence of that character B. So that's why we see 2 and we see sub count is not changed compared to the previous iteration. We haven't updated it because this character already reached the maximum frequency. So once it reaches, we should not increment the sub count in this case. Then in the next iteration, iteration 4, the end pointer points to the letter A and we check whether that letter A has reached its frequency. It's not yet, so we decrement the sub count, so it becomes 0. Sub count becomes 0 and we increment the count variable for letter A, so it becomes 2. So once this part is executed, then we check whether the sub count is 0. Yes, it is. Then we try to ignore the extra characters in the window starting from the starting pointer up until the end pointer. So here we cannot skip this A because the A needs to be present 2 times, so we cannot avoid this A. So we simply leave the start pointer as it is and then we compute the minimum window size. By subtracting 0 from 4 and adding 1, we get window size 5. Minimum window size will be 5 because 5 is less than the originally initialized value 32767. We updated the min window size here and then we slide the window 1 position. Okay, so basically start pointer is before sliding it was pointing to the 0th character. Now it is pointing to the first character. Once we slide here, we have to ignore, if possible, there may be some unnecessary characters. For example, this character is not part of the second string, so we can advance the start pointer until we see a character which is part of the second string. So that's what we are doing here. We increment the start pointer. After that, we ignore the characters. So from C, we go all the way up here because B also occurred more than its frequency time. So we just wanted to have bare minimal number of characters that is needed. In this case b, we want only one b, so we advance the pointer until we have this count reaches 1. Okay, that means the first time this will be advanced here. So in the ignore extra characters code, if you look at it, so we see the moment we see the character which has with whose occurrence is equal to the frequency, then we break out of the loop and leave the pointer. So in this case the pointer will stop at index 3. So after ignoring the unnecessary characters c and b, extra b, we pointing the start pointer points to the first b, and then the end pointer points to the next character, which is 0, 1, 2, 3, 4. So the start pointer is at 3 and the end pointer is at 4, and currently the minimum window size is 5, and we need to see one more character a, only then the window will be considered as containing the second string. Okay, so then in the next iteration the end pointer moved to position 5, and c, in this case c is not present in this hash map, so we just simply continue and incrementing the end pointer, and now the end pointer points to the last character, which is a, and that is not yet the current occurrence is less than its maximum frequency, so we decrement the sub count, so the sub count becomes 0. Then once we come out and then we increment this count of letter a in the hash map, so that we see 2. So once after that we compute the current window size, so which is starting the 6 minus 3 plus 1, which is 4. So this window size is less than the previously computed window size 5, so we updated the minimum window size to 4, and then we slide the current window and to one position forward, and then we try to ignore, but we cannot avoid any a character, so the start pointer will point to the position of 4, and then the end pointer pointing to 6, and then when we increment the end pointer we break out of the loop, because that is end pointer go past the maximum number of characters in the original input string. Then after we come out of the once we come out of the loop, we check whether the minimum window size is exactly equal to the max in. That means if in case if we haven't found any window which contains all the characters in the second string, then we have to return empty. That is what we are doing here. Otherwise we return the part of the first string starting from the index start idx up and until the start idx plus minimum window size. So in this case start idx plus minimum window size is 7, start idx is 3, so 0, 1, 2, 3, so b, a, c, a, so that is the expected output. Next I am going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. Let's see how many times the first and second for loop runs. So the first for loop runs 3 times, because there are 3 characters in this input string, and the second loop runs 7 times, that is equal to the total number of elements in the first string. So the totally time complexity is order of m plus order of n, so which is order of m plus n. And then the space complexity is order of m, because we need to allocate space for 3 elements in the char count hash map, because we wanted to maintain the frequency of each character in the second string. That is for the worst case, because if all the characters are unique in the second string, then we need order of m. Otherwise, depending on the duplicate present, it will go down. The space requirement will go down. So the time complexity is order of m plus n, and space complexity is order of m, where m is the length of the substring and n is the length of the first string. Thanks for watching this video. Have a great day.